Hi, I'm Martin Bailey from Global Graphics Software. Today I'm going to talk about how you can determine how much RIP power you need to drive a digital press by calculating the press data rate. Because here at Global Graphics we care a lot about RIPs, and we care a lot that our customers, often vendors building digital presses or digital front ends, DFEs, to drive digital presses, can develop efficient and cost-effective DFEs and get them to market on time. We've been doing this for many years, and we've learnt that the most important indicator of the amount of ripping power required to drive a press is the volume of data that the press needs to be sent when it's running at full speed. It sounds kind of obvious, doesn't it? But the implications for planning development work for a digital press are not always so obvious, which is why we made this video. Those implications are usually important for engineers and for product managers working for digital press vendors. I nearly subtitled this video, "What Product Marketing Just Asked For is Harder Than They Realize." Assume that a digital press is running at maximum speed, printing with as many colorants as it can use together, and that every piece of output, every page of the input PDF file, for instance, is different. How many megabytes or gigabytes of data need to be fed to the inkjet heads or toner drum per second? I realize that some presses have multiple print modes at different speeds and resolutions, and that the mode that requires the most data per second is not always the highest speed. I'd suggest calculating data rates for all of them and then just focusing on the one with the highest requirement. This bit is mainly for the geeks listening. I'm talking about uncompressed data because compression just moves the potential bottlenecks around the system between computing, memory, storage, and transmission. It has virtually no impact on the load on the RIP core. I'm talking about contone data at 8 bits per pixel, in other words with no half-toning applied. Ripping to 8 bits takes about the same amount of time as half-toning to 1 bit. The compute load to apply 1-bit screening is offset by the reduced size of the raster data to be copied around. Screening to 2 or 4-bit do usually take a little longer, but not enough to worry about here. And multi-level screening tends to get tangled in marketing anyway. The ripping and screening are sometimes separated within DFE workflow, so the RIP may really be delivering contone data, but that doesn't change the load on the RIP. And yes, I said 8-bit. If you really need 16-bit rasters, then you should do the calculations for 16-bit, but that's pretty unusual. And finally, I'm just talking about the load on RIPs in the DFE here. When you think about other parts of the system, such as storage, memory, or transport bandwidth, you'll probably need to take compression and bit depth into account differently. Exactly how you calculate data rate tends to vary between sheet and roll-fed presses, and some marketing may be a bit short on details for product comparisons, but the basis is always, what resolution am I ripping to, in both dimensions, because we're essentially counting pixels here, and a higher resolution means more pixels. How many colorants am I ripping to? That's usually the same as the number of inks that are available on the press. More colorants means more raster data to be delivered. And what area of output am I printing per minute or per hour, including both sides for duplex printing? Again, a faster print speed increases the number of pixels to be delivered. Another factor that has a significant bearing on RIP load is the run length. Let's assume for the moment that I'm printing 8.5 by 11-inch pages. It's going to be obvious how you can translate that to other sizes for other print sectors. And I'm printing at 600 by 600 dpi, with 4-color printing in CMYK, and looking at 8-bit per pixel output. The raster generated by the RIP for each page is around 128 megabytes. Now assume that I'm printing it on a 100 page per minute printer, and I want 1,000 copies of it. It's going to take 1,000 over 100, or 10 minutes to print. That's 600 seconds. If the following job is 1,000 copies of another letter-sized page, the DFE has 10 minutes to rip that next page before the press will be ready for it. The average raster delivery data rate required from the RIP is 128 megabytes, one page, in 600 seconds, or about 1/5 of a megabyte per second. But now imagine that I'm only printing 20 copies of each job. Now each one takes only 20 over 100 minutes, or 12 seconds on press, So the DFE has to prepare the following job in 12 seconds instead of 10 minutes. The average raster delivery data rate required from the RIP is 128 megabytes in 12 seconds, or a bit over 10 megabytes per second. And if I'm printing one copy, the DFE has only 1 over 100 minutes, or 0.6 seconds for the following job, meaning the RIP data rate must be over 200 megabytes per second. It shouldn't come as a big surprise that the data rate required for one copy of each job is 1,000 times the data rate required for 1,000 copies. I've phrased all of that in terms of single-page jobs, but you'll get the same numbers if you do the sums for multiple-page jobs as well. We've worked with dozens of digital press vendors, and our experience is that at least some print service providers, converters, or manufacturers will print jobs using significant amounts of variable data, or that have pages that are printed only once. And the proportion of jobs in those categories is growing. In other words, a press vendor needs to take that into account when assessing the load on the RIPs in their DFEs. We recommend that you at least work out what would be required to drive the press at engine speed when every page is different. You can then design an architecture that can deliver against those requirements and make informed decisions about how or if to scale the costs of the DFE back slightly if necessary. That way you won't find yourself needing to completely redesign the DFE if customers use more variable data on more unique jobs than you expected. If you genuinely believe that your press will never ever be used for prints where every item is different, and that your customers will never ever use a significant amount of variable data, then you can stop watching now. But that would be pretty unusual. So, how do you work out what the data rates around the DFE will be? Depending on the components you work on and what kind of press or sector of print you work in, you probably think about print speed in different ways. As examples, if you are working on B3 or smaller sheet-fed presses, you probably think in terms of pages per minute. For roll-to-roll presses, it might be width and linear speed. For B2 and larger sheet-fed, it's probably sheets per hour, or maybe sheets per minute. For wide format, it'll be square meters per minute or per hour. And the electronics guys usually think about head jetting frequency and nozzle count. And by the way, I'm suggesting those categories to help you get started rather than to constrain you. Global Graphics Software has published a data rate calculator based on Excel with sheets for people using all of those starting points. It's available at blog.globalgraphics.com/data rate calculator. And don't worry, I'll repeat that link at the end of the video. Incidentally, if you calculate data rates for the same press from more than one of those starting points, you'll probably get slightly different results. Sometimes that's because nominal values, especially around speed, have been rounded slightly by marketing. Other times it's because you're actually measuring different things. As an example, a B3 printer may be described as printing 120 pages per minute, because it prints 30 2-up duplex sheets in that time. But if you calculate from 30 sheets per minute, the data rate will be slightly higher than calculating from 120 pages per minute, because B3 is a bit bigger than 2 times A4. Don't worry about these kinds of differences. If you're looking at data rates to give you a foundation for designing your next DFE, then anything within 10 or even 20% of the correct value will be plenty good enough. So let's work through a few examples using the data rate calculator. And here it is. And as you can see, it's just an Excel spreadsheet. Down at the bottom, you can see there are a number of different sheets. This is the intro at the beginning, explains what it's all about. But then there are a series on pages per minute, web-fed, sheet-fed, square meters, and head frequency. Let's work through those one by one. And let's put in a series of numbers. Let's say we're doing a small format sheet-fed press that's printing at 100 pages per minute, and that's 1200 by 600 dpi in CMYK, that's 4 colorants. And you can see immediately that the data rate from that pages per minute is just under half a gigabyte per second. Nice thing about using Excel is that if I just want to say, what happens if I print at 1200 by 1200? Well, now I know. I get exactly what I'd expect, which is double the data rate of just under 1 gigabyte per second. Over here on the right, you can see I can configure what I mean by pages. It defaults to A4, but I can select US letter as well, and that changes the numbers just a little bit, not very much. It's the same kind of principle for WebFed. So if I want to set up a demo 2, and I'm going to say it's going to be 330 millimeters wide. Nope. Over here I've got configuration, and I've set the width units to inches. I don't really want 330 inches. So I'm going to go 14 inches. The speed unit is feet. So I'm going to say, let's say 100 feet per minute. And I'm printing one-sided because it's label press. I'm going to go 1200 by 600 again, and this time I'm going to print in, let's say, 7 columns. And now my data rate is 1.4 gigabytes per second. Obviously, I could fill in different variations on that. Sheets per minute is very similar. Let's say I'm going to go demo 3, and I'm going to say here I've got time period as an hour and units as millimeters. So I'm going to say I'm going to do, I don't know, 2,000 sheets per hour, and they're 750 by 550 millimeters. I'm printing duplex, and it's 1200 by 1200 dpi in 4 colors because it's duplex and therefore graphic arts, and that's more realistic. So that's about 4 gigabytes per second. If I look into wide format, grand format, kind of markets that talk in square meters per whatever. Let's talk about square meters per hour. So here we go with demo 4, I think I'm going to call it. And let's say 12 square meters per hour, quite a slow press. And it's going to be 720 by 720 dpi in 9 currents. So as I said, that's a very slow press, and it's got a data rate of 0.02 gigabytes per second, or 24 megabytes per second. And finally, for the electronics guys, let's say we've got a head frequency of 78 kilohertz, and I'm going to run with 8 heads, 2048 nozzles per head. And the electronics guys already know what head this is, and it's 1200 dpi. You know what, I'm going to go 600 along the substrate, and that's telling me that I'm doing about 200 meters per minute with a data rate of 1.25 gigabytes per second. And again, it's very easy if I could copy that and say what happens if I duplicate the bars to get a higher speed, to get a higher resolution along the web at the same speed, or a higher speed at the same resolution. And then finally, the last tab allows me to configure the bit depth that you're calculating. As I've said, the right one for calculating the load under RIP is almost always 8-bit content. You will occasionally have to think about 16-bit content, but it's very rare. And if you're looking at other parts of the system, you may want to be saying, what's the data rate for 1, 2, or 4-bit screen data? If you need to take compression into account, then you'll have to do some post-processing on the numbers that come out of the spreadsheet. And that's everything there is to it. So why does this matter? Well, obviously the engineers who build DFEs and interface boards for digital presses need to know this stuff. But why should anyone else care? The most obvious and common situation where it's valuable is when a digital press vendor is planning a next generation press. Product marketing will talk to a lot of current and prospective customers, and very often they'll decide that the new press must run faster to get more work through per shift, print at a higher resolution. That can be really valuable to retain fine detail in text, which is useful almost everywhere, but especially so for very complex scripts such as Japanese and others used in East Asia. It can also help with the smoothness of half-toned output. The press must have a larger colour gamut so that more brand colours can be emulated accurately, and that'll be achieved by adding process colorants, often one or more from orange, green and violet. And finally, it must have a white ink for printing on transparent, translucent and non-white substrates, and maybe also for haptic effects or even braille. Development work for the press hardware and electronics engineers will be planned in, but often nobody thinks much about the ripping at this stage. They should, and here's why. Imagine a narrow web label press, but bear in mind that the same discussion could be applied to any print sector. Let's assume that the current press is 330 millimeters or 14 inches wide, prints at 75 meters, 250 feet per minute, at a resolution of 600 by 600 dpi, and in 4-color, CMYK. That's typical of narrow web label presses sold in 2019 and 2020. The new press is slated to be the same width, but to print at 110 meters or 360 feet per minute, and at 1200 by 1200 dpi. It'll use a 6-color extended gamut ink set, CMYK plus orange and green, and white. That's pretty representative of what vendors are launching or working on right now. Let's use the calculator to work out the data rates for the two presses. So here's the data rate calculator again, and I have width units set to millimeters, speed units set to meters. So let's enter the old press. I'm just going to call it 2019. Printable width is 330 millimeters. It's running at 75 meters per minute. And single-sided for labels, 600 by 600 dpi, and 4 colorants, CMYK. So the data rate is just under 1 gigabyte per second. Now let's look at the new press. Call it 2021. Still 330 millimeters wide. Now it's 110 meters per minute. Still one-sided, but it's 1200 by 1200. And now we're in CMYK plus orange and green plus white. That's 7 colorants. And you can see the data rate for the new press is nearly 9.5 gigabytes. As the title on this slide says, this is where somebody usually says, "Oh wow," in a slightly worried tone of voice. The current press needs 900 megabytes per second of raster data, but the planned next-gen press needs 9,500 megabytes per second, a bit over 10 times more. That's because the new press is about 1.5 times as fast, 110 meters over 75 meters per minute. Doubling the resolution in both dimensions increases the data rate requirement by a factor of 4, 2 times 2. And going from 4 to 7 inks gives us an increase of 1.75 times. Multiply those figures together, 1.5 times 4 times 1.75, and you'll see where that 10 times increase in data rate comes from. As I said at the start of this video, what product marketing just asked for is harder than they realize. That's not an excessive press data rate by any means. Our Harlequin RIPs are used for driving presses that need multiple tens of gigabytes per second. But the current DFE that was designed to drive this current press, needing less than 1 gigabyte per second, is going to struggle to drive one needing nearly 10 gigabytes per second. Just adding more RIPs, RAM and storage into your existing architecture might not do it either. You may need to consider redesigning your DFE with a new architecture as well as the press and the interfaces. As I said earlier, you could be okay if you're only planning for it to be a short to medium run press. That is, if you expect your customers to never ever print a significant amount of variable data or unique prints. But if you build on that plan, you should cross your fingers that you're right, because your press is not the only thing evolving. So are expectations around where a print service provider or converter can make the best profit. And that means that run lengths are getting shorter, more variable data is being printed, and more jobs have completely unique designs. In other words, you really need to make sure that your development work on the DFE is on your plan for the new press right from the start. Otherwise, it'll almost certainly trip you up later. Just to put that example in context, here are the data rates for a few current and near future presses. Note the horizontal axis is logarithmic because the data rate for the fastest press in this chart is nearly 200 times higher than the slowest. These are deliberately not calculated to match individual real press models, but are based on relatively common press specifications. I've highlighted the two label press examples we've just been talking about in green. Incidentally, I keep meeting people who think that video streaming needs a lot of data. The recommended minimum broadband connection speed for streaming 4K UHD TV is in the range of 16 to 50 megabits per second or 2 to 6 megabytes per second. That's well off the left-hand side of this graph. Even a mid-range digital press requires something closer to the data rate for a Netflix server than to a domestic TV connection. So you've used the data rate calculator to give you the required data rate in megabytes or gigabytes per second. The next step is to translate that into the number of RIPs and the hardware specification that you need in your DFE. That will vary with your customer jobs and with the selected computing hardware. And the best way to make that next step is to talk with us at Global Graphics Software. We can work with you using our benchmarking tools. We can also demonstrate how some of our other technology components, systems and services designed for digital press vendors could help you to deliver an outstanding DFE while also reducing your engineering effort and time to market. There's obviously more information on the Global Graphics website at globalgraphics.com, covering our technology components for building DFEs, including Harlequin Direct and Core. If you have any questions or want to discuss data rates further, please don't hesitate to drop me a line at info@globalgraphics.com, and you can find the calculator at blog.globalgraphics.com/data-rate-calculator. And there are more videos on the Global Graphics TV channel on YouTube, including several on Harlequin Core, our RIP technology designed and tuned to help you drive even the very fastest digital presses. Thanks for listening, and I hope you found this interesting and useful.